Feel the burn.
Man, you go, girl.
Thanks.
How many calories have you burned?
200 and feeling good.
Wow. Wait, but what are calories? I don't know. What does that even mean?
I don't know.
Calories, in the simplest sense, are a measurement of energy, but we are not burning energy when we exercise. We are simply breaking down molecules that allow for the release of energy. To imagine this, think of 3 kids stuck in dress clothes on an uncomfortable pew at church. Mountains of energy are stored in their little bodies, and when the final amen is heard, they jump up and they go find their friend, which is a more favorable interaction.
We've all seen this equation in high school chemistry or biology, or at least we hope you have. This chemical equation shows us the chemical reaction that occurs in our cells during cellular respiration. Looking at this equation often leads us to believe that the energy comes from breaking glucose into smaller pieces. However, breaking bonds does not release energy, but rather it requires energy. When we look at the chemical equation, we want to see if the reaction is exothermic, releases heat or energy, or endothermic, requires heat or energy. A useful way to understand this is to think of molecules as magnets. Imagine that each magnet is an atom. When they are bonded or connected, it can require a lot of effort or energy to separate them. However, if they are already separated and brought close together, they will come rushing together without energy or effort needed to be put into the system. In fact, they release sound, which is a form of energy. We can compare how much energy it takes to pull the magnets or molecules apart and how much energy is released as the magnets or molecules come together. To do this, we will look at the bond enthalpies of the reactants and compare that to the bond enthalpies of the products. The term enthalpy refers to the heat absorbed or released from a system under a constant pressure. So when we refer to bond enthalpy, we are talking about the average energy it takes to break a bond between 2 atoms in a molecule. Comparing the bond enthalpy of the reactants to the products can help us determine if a reaction is exothermic. If the total bond enthalpy in the reactants is lower than the total bond enthalpy of the products, this means that the bonds of the reactants are weaker than the bonds formed in the products. Although it requires energy to break the bonds of the reactants, the bonds that are formed with the products release more energy. So heat is released, making this an exothermic reaction. The net bond enthalpy for the reactants in cellular respiration is 12,505 kilojoules per mole, and the net bond enthalpy for the products of cellular respiration is 15,144 kilojoules per mole. This means that it takes less energy to break the bonds in the reactants than it would to break all the bonds of the products. We now know that the products have stronger bonds than the reactants, which means that more energy is released when the products are formed in cellular respiration than the energy needed to break the bonds in the reactants. Although it looks like the energy came from breaking glucose into small pieces, the energy came from more favorable bonds being formed, which released energy. Therefore, cellular respiration is an exothermic reaction, and it is how our bodies get the energy we need. Now, some of us may think that we only burn calories when we exercise, which is not true. Our bodies require energy constantly to help us function. If this process of cellular respiration were to stop and we ran out of energy, then we wouldn't be able to breathe, move our bodies, or function at all. So we should be very thankful that we are constantly burning calories. Can you feel the burn?
You know I feel the burn, narrator. But wait a second. Does all the energy we take in and use up come from these sugars? Or what's the best way I can stay fit?
Beats me. Narrator? You still there?
That's a great question. Our go-to fuel source comes from the sugars we get from carbohydrates because our bodies are able to access that energy storage more quickly. Our bodies can also use fat as a source of energy, though it takes longer to get it from our bodies. Interestingly enough, though carbs are a faster source of energy, they're not as efficient. Our bodies can convert 4 calories per gram of carbs to usable energy, as opposed to 9 calories per gram of fat to usable energy. What exactly does this mean in maintaining a healthy lifestyle? Well, high-intensity exercise requires energy we can get from our bodies quickly, so it relies more on burning those easily accessible sugars. Low-intensity exercise is a slow burn, so our bodies can obtain energy over a longer period of time from our fat storage. Any source of exercise will require us to use energy, but if you're looking to lose fat, stick to cardio and other low-intensity exercise. How many calories you burn depends on your weight and speed of activity, But here are some examples: chewing gum for 18 hours, standing for 2 hours, or going on a 2-mile run will burn approximately 200 calories. There is some more science we can delve into, but we hope this gives you, dear runner, the information and motivation you need to live a little healthier.
Okay, so you're saying that when we burn calories, we're getting energy from our food, and the food is getting broken down and providing us with this energy?
Oh my gosh, yeah, people are so misinformed. We need to share this information with the world.
Yeah, we do.
Hey pals, have we got some news for you?